This is Chapter 4, Lecture 1. We're on page 49 in the packet, and we are going to start our discussion of the structure of the atom. We don't really have to get too involved in the history of the theory of the atom. In 400 BC, the thought was already underway that matter was made up of tiny, indivisible particles. I think his thoughts were that if you looked at a beach, it looked like one single thing, but as you got closer, you could break the beach up into smaller sand particles. And he reasoned that maybe that is how matter is composed. Around 350 BC, Aristotle thought that matter was made up of earth, fire, air, and water. This idea went unchallenged for over 2,000 years, so it was just a thought, no scientific background or experience or testing, and it lasted for 2,000 years. And then around 1800, as the scientific method became more used and experimentation was done, John Dalton came through with his hypothesis that atoms were composed of discrete particles, just like someone thought in 400 BC. The difference was, this time, it was based on experimentation. So John Dalton said that matter was composed of small particles called atoms. They are indivisible and indestructible. Now, just because he came up with this, that doesn't mean that's the way we think now, because now we know atoms are divisible into protons, neutrons, and electrons. Atoms of specific elements are different from those of another element. So gold is made of gold atoms, but silver is made of silver atoms. Atoms combine in simple ratios, and in a chemical reaction, atoms can be rearranged or separated into different substances. One experimentation that helped him come up with this model was the conservation of mass. And this states that atoms are not created, destroyed, or divided during a reaction. In this picture, all of A will combine with all of B to form C. On page 50, atoms are the smallest particle of an element that still retain the characteristics of that element. So a typical penny contains this many atoms of copper. That's 29,000 billion atoms, an undescribably large number. Why? Because atoms are unbelievably small. But once scientists were convinced that there were atoms, then the search was on to find out if it was composed of even smaller subatomic particles. Sub is below the atom. The first particle that was found was the electron. He found that there was a stream of radiation that traveled through an old cathode ray tube, which is a picture tube from an old television. Cathode rays were a stream of negatively charged particles. When he changed the metals in the electrodes, he found out it didn't affect the cathode rays, so they were considered to be part of all matter. These particles are now known as electrons. So the first subatomic particle found was an electron. An early explanation then of what an atom looked like was called the plum pudding model. There were spherically shaped atoms that had a diffused positive charge, and inside that cloud of positive charge were the electrons. This theory didn't last long due to experiments by Ernest Rutherford. What he did was he shot positively charged alpha particles, and we'll discuss later where those came from, out of a lead block towards a piece of gold foil. And what he found out was that as the heavy positive charged particles hit the gold foil, most of them passed straight through. But occasionally, one was deflected at an angle, and sometimes they even deflected back towards the source. He came up with a representation that inside of the gold metal, most of it was composed of empty space where the particles could pass straight through. But every once in a while, a positive charged particle, would get close enough to this dense central core of positive charge and deflect off of it. So in the Rutherford model of the atom, an atom consists of almost empty space through which the electrons move. Almost all of the mass is contained in the nucleus of the atom, which is a tiny, dense region of positive charge. How dense is the nucleus? If the nucleus was the size of a period at the end of a sentence, it would weigh 120 tons. How small is the nucleus? If a nucleus was the size of a nickel, the atom would have a diameter of 2 football fields. So unbelievably dense and unbelievably small compared to the atom it's found in. By 1920, he concluded the nucleus contained positive charged particles called protons. In 1932, a co-worker of Rutherford found that the nucleus contained another particle called a neutron. So now when we complete our model of the atom, we have a nucleus composed of protons and neutrons with electrons orbiting around the outside. The protons and neutrons are found in the nucleus. The electron is in the space surrounding the nucleus. An electron has a negative charge, a proton has a positive charge, and a neutron has no charge. If we give a proton a mass of 1, a relative mass of 1, a neutron would also have a relative mass of 1. An electron would have a mass so small that it's essentially 0. So our current model has a nucleus composed of protons and neutrons surrounded by a cloud of electrons. And that is it for lecture 1. We'll see you in class.